Hi, in one of my previous videos I showed you how you can find the derivative of x to the power x. We actually found the answer to be x to the x into 1 plus the natural logarithm of x. Okay, so today I'm going to take this one step further. I'm going to find the derivative of x to the power x to the power x to the power x and so on up to infinity. Okay, this looks interesting and weird. So let's go ahead and do that. So the first thing I'm going to do is to let y to be equal to x. So let me use the exact colors that I have here. I think that will become more visually interesting. X to the power, so I write the powers in yellow, to the power x to the power x, and so on. Okay, so we have many x's. We can't finish them all. They're just continuous. Now, the technique that we used when we evaluated the derivative of x to the power x was to put natural logarithms on both sides. And I'm going to do that for this problem too. So let's introduce natural log on both sides. So the natural log of y equals the natural log of x to the power x to the power x to the power x, and so on. All right. Okay. So what's the derivative of the natural log of y? That's 1 over y dy dx. And okay, just to make this still look good, I'll use a different color here. 1 over y dy dx. And the derivative of this, now before I think actually let me simplify this before I actually take derivatives. So this is the derivative, the natural log of y. So what's this? I can actually write this as x to the x to the x and so on. This power here, I bring it behind here, and then I have the natural log of the original x that was there in blue. Okay, I think this is mathematically true, but you see, x to the x to the x to the x and so on is the same as y because we don't know how many x's these are. So this thing here is the same as y, so I'll write that as y, and then I'll write the rest again, the natural log of x. What's that in blue? Okay, natural log of x. Then here I have the natural log of y. Oops, actually confusing the colors. Okay, I'll just go with green. Okay, nice. So we have the natural log of y. This y is actually the same as this y. No big deal here. Okay, so that's the natural log of y equals y times natural log of x. Okay, so there we go. Let's take derivatives on both sides. The derivative of natural log of y, let me do that in white. That's going to be 1 over y dy dx. What's the derivative of y times the natural log of x? Let's use product rule. So if I keep y constant, the derivative of natural log of x is 1 over x, right? Then plus if I keep natural log of x constant, the derivative of y is dy over dx. Okay, so almost there. Let's collect like terms for dy dx. So 1 over y, that should get this, 1 over y dy dx minus the natural log of x times dy over dx. That's equal to y over x. Yeah, that's y times 1 over x. That's y over x. So just factorize out here, 1 over y minus the natural log of x times dy dx. This is equal to y divided by x. Alright, so I can actually simplify this, and that's going to be y. That's 1 minus y natural log of x dy over dx. All this is equal to y over x, and almost there. So I can now write my dy dx as y over x times, okay, that's going to be y over 1 minus y, just a little bit better, natural log of x. All right. Okay, so that's good. So now we have y squared divided by x. What's that going to be? Okay, x minus xy times the natural log of x. Okay, remember this is dy dx. So I think it's better that we do not leave any y's in our final answer. So I'm going to substitute back for y as x to the x to the x to the x. Okay, and I guess it's going to look ugly, but we have no option, so let me do that. Also create some extra space here. Okay, let's use a yellow color now. So finally dy, oops, I have to get a pen. So dy divided by dx is going to be equal to, so I'll write this instead of y squared, I'll write this original y here, that was x to the x. Okay, just to show you that this is the original y, I'll just put back these x's. Okay, all this is squared divided by x minus, okay, so, you know, this, don't mind about the colors, so that's x minus x natural log, sorry, that's xy natural log of x. Oh, I actually don't want this y here, so I'll go try this as natural log of x to the power y. All right, and then I'm going to substitute for that y also, so I have x. Okay, I have x to the x to the x, all this squared divided by x minus x natural log of x to the power x, 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 and so on. So okay, that's interesting because we don't know how many x's they are, so there is no further simplification we can do on this. So I don't know, I think I can write this as x to the power, you know, this is, the power is x to the x to the x, infinity up to infinity, and then all this power is squared. So I guess I can multiply these powers. Maybe I can write this as 2 into x to the x to the x, like that. And then I can factorize out x from the denominator. That's 1 minus natural log of x to the x to the x, and so on. And then this is x, so because these are similar bases, I can work on the powers. So I'll write this finally as x to the power 2 into x to the x to the x, and so on. All this minus 1 divided by 1 minus natural log of x to the x to the x, and so on. All right, so this is a very interesting problem. Let me know what you think in the comments. Don't forget to subscribe. Also turn on the notification bell so that you're notified every time I upload an interesting problem. If you have an interesting problem, you can also leave it in the comment section below or write it to me by email. I'll try to work on it. So thanks for watching. See you again.